Hey everyone, we're back for more math. That's fantastic. Today we're on lesson 1-11. Order matters and also doesn't, weirdly. And then also thinking about assumptions. So we're going to talk about whether order matters and placement matters. We're going to talk about proportions and factor puzzles. And the answer is it does matter. And also it doesn't matter, which is a weird answer. So let's get to it. Let's think of our analogies. Here's one for us. Cows and milk and chickens and something. Now, if we put it into a factor puzzle, it's kind of silly. We've never really thought of putting just words into a factor puzzle. But remember, factor puzzles and analogies have a lot in common. So when we were making the brew yesterday, we put in cows and chickens and ratios and analogies all into the mix. So let's take a look. Cows has a relationship with milk. Remember, those two sets of colons mean in the same way that chickens have a relationship with something. Well, this is probably kind of an easy one. What is the relationship between cows and milk? Cows make milk and, we drink it, we eat it. Drink. In the same way that chickens make something that we eat or drink. Well, eggs. Yeah. So hopefully you're like, well, that's kind of an easy one, Miss Gurud. Why are we even talking about this? Of course, chickens make eggs and cows give us milk. So I'm going to write the word eggs in. Cows give us milk. Notice how the cows give us milk. It goes first, the thing that makes it, and then what is made, what we eat or drink. Over here, it has to be the same order. So if cows, the animal comes first, and what it gives us comes second, then here the animal has to come first and what it gives has to come second. In order for that to be an analogy, cows give us milk and that has the same relationship as chickens giving us eggs. Now, the same is true if we put it into a kind of a factor puzzle. Cows give us milk, chickens give us something. Let's put the labels. They're not going to be numbers around the factor puzzle. This time they're going to be word labels. Let's put the labels around to see if it matters where we put the word cows or where we put the word chickens or where we put the word milk. So this is cows and chickens. So this column is animals. I'm going to name that the animal column. This column has milk and something. We figured out that something was eggs, milk and eggs. So I'm going to label that the food column. So we have cows and chickens in the animal column and what they give us in the food column. Cows give us milk, chickens give us eggs. But what if I did the exact same thing but switched the words around? Notice how I put the words in a different spot. Is that okay? It is okay as long as we keep ourselves organized and make sure the labels match and they go in the spot with the labels. So let's check this out. This time we have chickens and cows in a row. Where am I going to put the label? In the row. I can't put animals up here because look, this is chickens and eggs and cows and milk. So I've got to put the label animals there. Now that row is labeled animals. What about this? There's the milk. There's the eggs. Now I'm going to put the label of the food over there. Does it still work? What about if I switched the order up here? Chickens have a relationship with something in the same way as cows have a relationship to milk. Cows give us milk. So cows comes first, milk comes second. Chickens give us eggs. Notice the analogies look different. And one of them has the factor puzzle with the columns being labeled. One has them with the rows being labeled. But do they all work? They do still all work. That's why order matters and also doesn't. That's the same thing with a factor puzzle. Remember, you might have bigger numbers on top and smaller numbers on the bottom, which isn't how a multiplication chart goes. But as long as they're in the right row and in the right column, you're in great shape. Now let's take a look on page 34. Weirdly, we're going to skip 33 for just a little bit, and we're going to take a look at page 34. We will come back to 33. So in your book, go ahead and grab your book. If you don't have it, grab your book and open it up to page 34. All of these factor puzzles are about Jim and Ann. Notice that sometimes Ann is labeled first in the left-hand column, and sometimes Jim is labeled second in the right-hand column. Sometimes Jim is labeled first in the left-hand column, or Ann is labeled first in the right-hand column. We could even label Ann and Jim on the sides, on the rows. But we have to put those labels in because then we know where to put the numbers. Because all of these problems are all the same. Ann is making 35 posters. At the same time, while means at the same time, she's making 35 posters at the same time that Jim's making 14. So wherever we put Ann, we have to put her 35 there under her. And look at this. We could put her 35 under here, her right up at the top. There's Ann and there's the 35. Let's see if I can get my circle pointer to work. Oh, it's still not working. Okay. Well, that's just not working right now. But look down here. Here's Ann. She's still on the left, but this time the 35 is down on the bottom left-hand corner. Up here, 35 was on the top left-hand corner. Over here, Ann is on the right, and it's in the top right-hand corner. That's exactly the same as we just looked at with our cows and our chickens and our milk. As long as the column matches up with the heading, and as long as the numbers that go together match up, like Ann's making 35 posters at the same time that Jim's making 14. So 35 and 14 have to be right with each other. As long as those things are the case, we can turn it and turn it and turn it all around as much as we want. So take a close look on page 34 at those. Don't worry about this number 4. I'm going to actually cross that off. Don't worry about that. But what I do want you to worry about is completing the sentence. You can switch the blank or the blank in a factor puzzle and still have the same proportional relationships. We could switch the rows, or what else did you see when we were doing the milk and eggs and cows and chickens? Columns. We just saw that for Ann too. Sometimes she's in the left, sometimes she's in the right. So rows and columns can switch as long as we stay organized and put the information, the data in with the correct label. Let's go back to page 33 now. All right, here we go. We're back to thinking about making assumptions. Remember, when we talk about make assumptions, we know that in life, things don't usually happen at a constant rate. Things happen that make it different. If I go out collecting, I don't always find the exact number of rocks. If 2 bands are marching out on the field, we know that they don't march exactly at a constant rate, every single person. But what assumptions are we making in order to be able to do constant rates and therefore have 2 constant rates and put them together into ratios and then have equivalent ratios into proportions? See how it all kind of falls down one after another. We've got to think about assumptions. Remember, the best way to think about assumptions is play the what if game. And the answer always, nope, that didn't happen. So 2 bands march out on the field. They're on the football field. When band A has 15 people on the field, band B has 6. So there's 2 bands. You think of a band competition marching out, 2 bands marching out. When one has 15 come out onto the field, another one has 6. Now it says the one that has 6, when they have 14 people on the field now, how many will band A have? What are the assumptions? Let's play the what if game. What if someone didn't show up that day? They got sick. Nope, didn't happen. Everybody's there. What if someone was busy looking over the crowd? You know how sometimes people will like see someone they know and they're waving over at the crowd. Nope, that didn't happen. What if someone tripped? Nope, that didn't happen. What if someone just isn't paying attention, is just kind of leisurely that day, just walking slow? Nope, that didn't happen. All of those what ifs that the answer is, nope, that didn't happen. Those are the assumptions. We assume nobody's sick. We assume nobody's distracted. We assume nobody's going faster or slower. We assume nobody's tripping or having a hard time. All of those are the assumptions that we make in order to make sure that the two bands can march at a constant rate the whole exact time. Now, so you're going to write those assumptions that we just talked about on the lines. And here in the factor puzzle, you're going to start with these two big headings. That's how you're going to know where to put your stuff. What are the two things that are going on? Well, it's band A and band B, and they're marching. So here's band A, and here's band B. Now, you can actually write out band A and band B there if that helps you. It's just that I'm not very good at writing with my computer. So I'm just going to abbreviate band A and band B. Now I know that every number that has to do with band B has to go on this side. Every number that has to do with band A has to go on that side. I'm going to fill in the information after I reread. Two bands are marching in rows. Band A has 15 people. Okay, so I know I'll go under band A, and I can put it on the top or the bottom. Doesn't matter. I'm going to put it on the bottom because I feel like it. So band A has 15 people. Now, it says when they are doing that, when they have 15, that means at that exact time, when they have 15, band B has 6. Now, I know I have to put the 6 under band B. I can't put it anywhere. It's happening at the same time as the 15. So I know I have to put the 6 in the same row as the 15. When band B has 14 people on the field, now we know band B has 14. Where are we going to put that? It's got to go under band B. There's only one spot. So it says when they have 14 people on the field, how many people will band A have? There's our factor puzzle. Go ahead and solve it. All right. Number 2 is one of my favorite what if questions. One of my favorites to think of assumptions. An aquarium has 32 angelfish. Do you know what angelfish are? They're a beautiful, beautiful fish that have big, long, flowing fins. Now, keep in mind, I am not the greatest artist ever, but they kind of look like this. They've got these big, long, beautiful fins. Like that. They're beautiful. How big are they? They're probably about, they can be anywhere from about this big, like probably this big, all the way up. I've seen some angelfish that are this big. An aquarium has 32 of them. 32 angelfish for every 12 snails. How many snails will be when there are 72 angelfish? Okay, so stop and think about this a minute. This is a big what if. First of all, how big would the aquarium have to be to hold 72 angelfish? Huge. It'd have to be like the size of the wall. So there's one assumption. Your aquarium can hold all those. What's another assumption? Well, let's play the what if game. What if some died? Nope. None of them died. There's 72 angelfish. What if some of them had babies? Nope. None of them have babies. What if you were trying to count the snails and they went in those little, you know how people who have aquariums have those little hidey spaces, little sunken ships and that sort of thing? What if you miscounted? Nope, you didn't miscount. So those are your assumptions. We assume that the aquarium is big enough. We assume that none of them have babies. We assume none of them die. We assume we don't lose count, for one thing, because there's so many of them. We assume we don't miscount by some that are hiding or something like that. All of those are the assumptions that we're making in order for this to be a constant rate for the angelfish, a constant rate for the snails. We put them together and we have a ratio table. From that, we can make a proportion. And how to solve that? using a factor puzzle. Good luck. Email me, chat me, call me if you have questions. Come and visit me on my office hours. See you next time.